Hello everyone. In this truss, we are going to find the member forces in ML, LB, BC, and in JN. We are going to use the method of sections. In this truss, there are 5 loads. All of them are inclined, but these loads are perpendicular to the line AJ. That means here we have 90 degree, here 90 degree, here 90 degree, here 90, and here 90 degree. In this truss, in the point A, there is a hinged support, and in the point F, there is a roller support. In the hinged support, there will be 2 reactions, and in the roller support, there will be only one reaction. We need to find these reactions. Before, we have to find this angle, and we have to find this distance. From the joint J, let us make a vertical line like this. Let us take this triangle. In this triangle, let us find tan theta. That will be the opposite side, which is 4.5 meter, upon the adjacent side, which is 6 meter. From these, for theta, we will get 36.87. Now let us use a sin theta formula. That will be the opposite side, which is 4.5 upon AJ. In this way, for AJ, we will get 7.5 meter. We have calculated the length of AJ. The length of AL should be AJ upon 2. In this way, we will get 3.75 meter. About AJ, these 5 loads are symmetrical. In this case, we can find the resultant in the center L. We need to add all of the loads. When we add, we will get 160. Now we are going to find the reactions. To find VA, it is a little difficult. So first, let us find VF. To find VF, let us take moment about A. Let us keep clockwise as positive and anticlockwise as negative. BF is acting in the anticlockwise direction, so that it will be negative, and the distance is 12. The resultant 160 is acting in the clockwise direction, so that it will be positive. We have to take the distance of AL. We have already calculated it is 3.75. For VF, we will get 50 kilonewton. Now we can apply this rule and find VA. VA and VF are acting upwards, so both of them are positive. We have to resolve the resultant in the vertical direction. We need to find this angle. We know that this angle is 90. So if this angle is 36.87, this angle also should be 36.87. Since the resultant is acting downwards, it will be negative, and then we have to multiply with the cos 36.87. In this way, for VA, we will get a 78 kilonewton. Now let us apply this rule and find HA. HA is acting towards the left side, so it will be negative. We have to resolve the resultant in the horizontal direction. We need to find this angle. This angle will be 90 minus 36.87. So it will be 53.13. Since the resultant is acting towards the right side, it will be positive, and we have to multiply with the cos 53.13. Finally, for HA, we will get 96 kilonewton. Before making the sections, we have to find some distances. From the point L, let us draw a vertical line. Let us keep this point as L dash. Now let us take this triangle. In this triangle, let us use a sine formula. That will be the opposite side LL dash upon the hypotenuse side AL. We know the distance of AL, which is 3.75. Finally, for LL dash, we will get 2.25 meter. Now we can use the tan formula. Using the tan formula, we can find AL dash, which is 3 meter. Now let us take this triangle. We know that here we have 90 degree. In this case, in this triangle, we can apply the trigonometrical formulas. We know the distance of AL 3.75. When we divide that by 2, we can find AM, which is 1.875 meter. By applying cos formula, we can find the AB. Then using the tan formula, we can find out the distance of BM. We need to find the member forces in ML, BL, and in BC. To find these three, we have to make a section like this. We can take the left side portion. We can extend these two members up to L. To find FLM easily, we have to take a moment about B. When we take a moment about B, we should not consider 40, FBC, FBL, and 96. The remaining forces are 78, 20, and FLM. 78 is acting in the clockwise direction so that it will be positive and the distance is 2.343. FLM is acting in the clockwise direction so that it will be positive. Here we have 90 degree, so we can easily take this distance, which is 1.406. We can resolve 20 in the vertical direction. To keep it in the vertical direction, we need 36.87 degree. About the point B, it is acting in the anti-clockwise direction so that it will be negative and the distance is 2.343 and we have to multiply with the cos 36.87. For FLM, we will get a negative value, that means it is compressive. To find FBC easily, we have to take a moment about L. When we take a movement about L, we should not consider FLM, FBL. The remaining forces are 40, 20, 96, 78 and FBC. FBC is acting in the anti-clockwise direction so that it will be negative and the distance is 2.25. 78 is acting in the clockwise direction so that it will be positive and the distance is 3. 96 is acting in the clockwise direction so that it will be positive and the distance is 2.25. These two loads are acting in the anti-clockwise direction, so both of them are negative. For this load, the distance is 1.875 and for this load, the distance is 3.75. For FBC, we will get a positive value, that means it is tensile. Before finding the member force FBL, we need to find some angles. This is 36.87 and this is 90. So this angle should be 90 minus 36.87. So it will be 53.13. These two triangles are having the same dimensions. So if this angle is 53.13, this angle also should be 53.13. Then we can easily find this angle. This angle should be 180 minus 53.13 into 2, so that we will get 73.74. To find FBL easily, we have to take moment about A. When we take moment about A, we should not consider 96, 20, 78, FLM and FBC. The remaining forces are 40 and FBL. 40 is acting in the clockwise direction so that it will be positive and the distance is 1.875. We can resolve FBL in the vertical direction. To keep it in the vertical direction, we need this angle. This angle will be 90 minus 73.74. So it will be 16.26. About the point A, FBL is acting in the anti-clockwise direction so that it will be negative and the distance is 2.343 and we have to multiply with the cos 16.26. For FBL, we will get a positive value, that means it is tensile. We have to find one more member force, that is JN. Now let us take this triangle. We know that here we have 90 degree. Using the cos formula, we can find the distance of AC as 4.687 meter. To find the member force in JN, we can make a section like this and we can take the left side portion and do the analysis. To find Fjn easily, we have to take moment about A. When we take moment about A, we should not consider 20, 96, 78, Fjk and Fcd. The remaining forces are 40, 40, 40 and Fjn. We can resolve Fjn in the vertical direction. To keep it vertical, we need this angle. We have already found this angle as 16.26. Now Fjn is acting in the anti-clockwise direction, so that it will be negative. We have to take the distance of AC. Just before we have calculated that as 4.687. Then we have to multiply with the cos 16.26. These three loads are acting in the clockwise direction, so all three of them will be positive, and we have to multiply with the corresponding distances. For Fjn, we will get a positive value, that means it is tensile. Now we are going to end this session. Thank you for watching this video.